Good day. This is Russell from the Tate Geological Museum, and today I'm talking about a particular type of fracture called cleavage. We discussed earlier how different minerals will break in different ways. There are many different kinds of minerals that will break along a perfectly flat, smooth plane, and that's called a cleavage plane. And one of the best examples of this can be found right up on top of Casper Mountain. Nose around there and keep your eyes open, and you may very well find this stuff. So can anybody tell me what this mineral is right here? Yeah, points to all of you who said mica. This is mica. And mica is a very good example of a mineral with perfect cleavage. Here's a nice little chunk here, and if we split this in half, bink, it has broken along a perfectly flat, smooth plane, a cleavage plane. Now, mica is an example of a mineral that only has one plane of cleavage. This mica that I just broke, it'll only break like that. It wouldn't have broken like this or like this. It only has that one cleavage plane upon which it breaks. Now, that's not true of every mineral. There are other minerals that have multiple cleavage planes. And of course, there are minerals that don't have cleavage planes at all. But here's an example of a mineral that has two cleavage planes. Does anybody know what this is? Yeah, that was a tricky one. This is gypsum. And gypsum has two cleavage planes. You can see one of them quite easily right along here. And here's the larger cleavage plane on this specimen. And then you can just make out another cleavage plane running here on this guy and running along here on that guy. This cleavage plane is much better than that one. It'll break more easily along that cleavage plane. So you don't have to stop there. There are minerals that have three cleavage planes. And here's a good example of a mineral that has three cleavage planes. We've got one here, and one here. And if I broke this mineral, it would break along those three cleavage planes to make fragments smaller than this, but this same shape. Notice that these three cleavage planes are at the same angle, 90 degrees, relative to each other. So we've got, what do you call a 90-degree angle again in geometry? Yeah, a right angle. So here's a right angle here, and then we've got a right angle here, and these two meet at a right angle as well. So it breaks up into little cubes. You may have this mineral on your dinner table, and if you were to take a handful of that stuff and look at it under a magnifying glass, you would see that the fragments are shaped like little tiny cubes. What is it? Here's a hint. Salty. Yes, this is halite, and halite is table salt. It's the exact same stuff made out of sodium and chlorine atoms bound together, and it has three planes of perfect cleavage. And they are at right angles to each other. Now that's an important point because there are other minerals that have three cleavage planes not at right angles to each other. How about this stuff? At first glance, you might think, oh, it's a piece of halite, right? Nope, not halite. Now, tasting it is cheating. There's another way that you can tell by looking at the cleavage planes. We've got one here, and one here, but they are not at right angles to each other. This cleavage plane meets this cleavage plane at an angle that is less than 90 degrees. Does anybody remember from geometry what you call that kind of an angle? Less than 90 degrees? Yes, that's an acute angle. Very good. But then these two planes, here and here, are meeting at an angle that's greater than 90 degrees. And what do we call that angle? Oh, yep, obtuse. Nothing obtuse about you. That's correct. And those angles are always the same. Here's a piece of calcite, and here's a piece of calcite. Some of these areas here have broken off, leaving behind these little hollow areas, and this fits in there perfectly, absolutely perfectly. You might think, okay, so you put it back together again, big deal. Except if I take this piece right here and fit it in there, perfectly. It fits absolutely perfectly. Why? Because those cleavage planes always meet at the exact same angle. So you can have a piece of calcite that's from Wyoming and another piece that's from New Mexico. and yet when you fit them together, they fit together as if they were originally part of the same specimen. And then the last mineral I'm going to show you is one that has 4 cleavage planes, and that's this stuff right here, fluorite. And when fluorite breaks, it doesn't break into cubes along 3 cleavage planes. Instead, it's got 1, 2, 3, and 4, and it forms fragments that are shaped like octahedra. So if you're looking for minerals and you're trying to identify them, this is a good way to do it. Find out, first of all, does it have cleavage planes? Second of all, how many does it have? 1, 2, 3, 4? And then also note the angle at which those cleavage planes intersect. And once you've answered all those questions, you'll be well on your way to nailing down exactly what kind of mineral you've got.